Hello, welcome back to Blender Sushi, another live noding session, and today I'm going to take you through this another exploration of BVH in animation nodes. The setup we're gonna create is something like this, where you might have like a bunch of objects you want to place on the ground, and just like this, Suzanne, and if you're doing like a 3D layout kind of work, if your job is like layout artist, you might want to use something like this. There might be script outside that already do this, but anyway, we're gonna do a little bit of explorations of BVH inside animation nodes and how we could implement something like this. Okay, yeah, so let's just do it. Let's go and start new Blender. We're gonna go to compositing. I actually just created this setup earlier this morning. I got an idea, and because the other day I was trying to do this rigid body dynamics, and then I scatter some objects in the space, and then I realized that some objects are intersecting, and I was wondering if we can use something like animation nodes to kind of figure it out, whether objects are intersecting, and then maybe wiggle the objects slightly so they are not intersecting, but they are. Yeah, from that idea I was starting to think, okay, maybe do this first, like placing objects on the ground. Yeah, maybe that's for another lesson. If you want to like kind of wiggle objects so they're no longer intersecting for rigid body dynamics. For today, we're gonna do something just slightly simple first. Let's delete that objects for now. We're gonna use a grid. Okay, center the grid. Let's scale it up. The grid is gonna be our ground. I'll name my objects for now, and just use displace modifier. Just gonna displace it using texture, direction of normal. For the texture, just use cloud and increase the strength, and maybe smooth it. Control 3 is to smooth, and I'll make the ground smooth. That probably should be okay. Then we get to animation nodes, create a new node 3, and let's have like cube object for now, and we want to drop this cube. Maybe have like 3 cubes to test. And for now we don't okay, don't worry, I'll just gonna group our objects. Control G. The objects are grouped, and the ground. Okay, let's bring in to animation node. So with the ground, we can use the object mass data. There's also the BMesh mass data and BMesh from objects. Actually, BMesh from objects probably better for the BVH thing. So let's just grab our ground object, and then let's get our objects from group. So the group, with the group selected, we can iterate over each object and then checks for whatever BVH interactions it's having. So I just created a loop just now. It's a W hotkey, just in case you don't know. So I'm iterating through each object in the loop, and I want to bring in this BVH construct as a parameter. BVH3. So with bmesh to BVH3, you need to construct it first. Construct BVH3 from bmesh. Okay, and with BVH, let's see what we have. There's a raycast and there's a construct, but then there again, there is this raycast find nearest is inside volume. Is inside volume is probably what we need for now. So BVH, just plug that in. You have seen this before. I was using BVH, and then but I haven't shown you what we can do with all this. There's actually a lot of things we can explore with a BVH. It's kind of unexplored territory for commoners like us, like for Blender artists. The developers might use this a lot, but normally Blender artists don't use this much. We don't usually access this kind of stuff because it's kind of complex, but with animation nodes we get a little bit of bridge to help us to deal with this kind of complexity. So yeah, anyhow, with our objects here, the 3 cubes, we could monitor those guys like this and check for their location. Now with this setup we can already get something. Let's debug loop it real quick. I'll plug this in and then check this loop. It says false, false, false. But if I move the objects, wait a minute, this not seems to be working. Oh yeah, so the center points need to be touching because it's currently it's only monitoring the object's position, which is of course just the center of each object. But if the center is touching the ground, then it's gonna give like a true. See, it's true, false, false. To be really clear, I will so I say this is our object list, right? And then this is our debug loop, and the debug loop itself is actually interactive. If we plug in the object and then have a look, okay, let's turn on also the numbering, false, and BPY struct object, blah blah blah. We only need the name of the objects, so we could use like object attribute input. So it's kind of nice to have the debug loop like this. You in a like a Big Brother software like Houdini, you have like a spreadsheets that can tell you about every attribute. It's a big spreadsheet list, but with the animation nodes, this is a good way to see this kind of thing. So with our object, we can just get a name, and that value just plug that into this guy, and that. So we have something like this. Maybe it could be nicer if we have like a, if the list can be more what do you call it, aligned on the left, but that's okay, kind of. So we can tell if which object is touching. So let's say this this is a cube, and then I'm make the center touching the ground. By some kind of magic, we can tell now, okay, that cube is true. So if it's touching the condition, the boolean, it will tell you that, okay, the object is actually touching the ground, and that's actually exactly what we need for our setup. We want the objects to keep moving down until it's touching the ground, and if it's true, then stop moving. Okay, let's see, BVH touching. So if it's touching, just stop moving. So you might have or have not seen the previous video I did on talking about animation nodes magic node, which is which keeps monitoring the objects we are selecting, and then with the object selected, just keep doing something until we stop selecting them, something like that. For now, we will, since we already have the objects inside the group, so we don't, later on I will show you anyway. So I want the objects to keep moving down, and then in order to do that, we can use transform object. This is one of those magic nodes because it's doing simulations without even the, having the playback playing. So it's almost like a solver. Here we can, I'm gonna leave the debug loop, but let's concentrate on this transform objects and use the center. Yes, use center, and then let's have a switch. Okay, the switch is expecting a conditions. The setup, what we want to do is for animation nodes or Blender to check if the object's center points is touching the ground, and then stop moving. If not, keep moving. Okay, so we need a compose matrix. Okay, with the compose matrix we have translation, rotation, scale, but really what we need is just the translation matrix to keep things simple. So translation matrix, I just create a duplicate, and then I want the objects to keep moving down, like, so I give like -0.2. So with the conditions, it's gonna check if it's if the object is touching the ground, stop moving. So if the condition is true, then stop moving. So stop moving is like 0, 0, 0. If it's not touching, keep moving. That's this is actually called conditional in programming. It's checking for a certain condition, and then if the condition is met, then it will do either of these, true or false. Okay, and I'll just plug that in and plug the object in. At the moment, the animation node is set to always, so it's always calculating here. So we could turn that off and execute node step by step. Let's see the difference. So now we have all the setup. If I execute the node step by step, it's gonna keep moving the objects until the condition is met, like here. See, when it's all true, the objects just stop moving. We already have like the beginning of our setup happening. So just now I was running the setup frame by frame, or I mean not frame by frame, iterations by iterations. Like every time I click, it's gonna check, is the objects touching the ground? No. If no, keep going. So we can of course turn this on to always. So it's almost kind of like a simulations. You probably can do this using Blender rigid body dynamics, but of course you don't always want to use dynamics. I mean, this kind of thing you probably can use Python script. That's probably the best. Yeah, so we have it. So we have the setup ready for us. If we have like other objects like this guy, and then maybe Suzanne head. So we have this guy and this guy, and we want to do this. We could use the magic node. So instead of having to group the objects, you can also use the get selected objects node. So this is the magic node I was talking about. So it keeps checking for selected objects in the 3D view. It can be a little bit dangerous because it will react right away. So for every object selected, it's gonna start doing whatever you have here on the animation nodes. Depends how you set it up. If you accidentally select, like, if I select the ground, for example, and then okay, the ground is actually checking against itself, so that's okay. But anyway, it can be a little bit dangerous, so just be careful. So because it's keep checking for whatever happening in the scene. So our setup is by now our setup is ready, but of course it's currently only checking the center of the objects. We actually want it to be a little bit smarter, where it checks every point of the objects. Okay, so we can make it that way. So at the moment, of course, like I said, it's only checking of the center of the objects. It says I pipe in the location into the vector. What we want is to check for every vertex whether it's touching or inside of this mesh. So probably a more clever setup is where we compare two BVH 3 objects and then see if they are touching. But that's probably for later video tutorial. But for now, let's see how we could do this. Let's get rid of the loop. For now, we don't need to check. So what we need is a loop inside the loop. So here we got the objects, and we know we are not checking the location anymore. What we want to check is the vector. So with object mesh data, this is already inside the loop, right? And if we plug in the objects into object mesh data, you know how it looks into the vertex, the position of each vertices here, and we can have the BVH 3 inside this guy. Let's see, I'll just hit W and then loop through the vertex locations, and let's see what oh, we lost that node. in. So we need another little loop inside this loop to check for each object vertices, which is the vertex locations. Please check if the BVH is touching the vertices. Let's quit the camera. Okay, let's use modifier. BVH3 goes in, so we need to create BVH3 slot here. BVH3. And then we're gonna do the checking inside here. I'll disconnect that. So if it's inside, the output is gonna be the boolean list. So it's gonna do like a quick calculations for every single vertices of that objects. Okay, that's what we need. So that's our little loop, and we can debug loop. Okay, debug loop and check. The list might be a little bit big. Actually, okay, calculate always. False, 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 false. Okay, that's for that cube. If we have that cube and that cube, false, 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 false. All right. So next we want to have there's a boolean list logic that can be handy. I just found out about this morning, and then hey, we have boolean list logic, and then with this boolean list logic, it's kind of like a loop, another little loop inside it. But this is like a really handy node to check if any of the vertices is touching that ground, which is from our boolean list. If not all true, then give a result. So now we actually almost have it ready. So let me use debug loop. To be clear. True. Okay, we'll create object attribute input once again. I'm gonna save this real quick. So for that object, just grab the name and then pipe it into debug loop, and then we also want to check the boolean list. So true, cube, false, false. This with debug loop, we actually have the option here to resort the order of the data. So okay, that's nice. Save it again. So now with this cube true, false, 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 false. It's true, that means not all true, not all false, not all true. Correct. I was expecting it to be saying false, but if I plug in, if not all false. It should be not all false. That's correct. So here, okay, let me explain. Like I said, it's checking for every vertices of selected object. So if the selected objects by default, if the object is not on the ground, should be if it's on the air, it's gonna be false, 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 false. If not all false, which means there's like a okay, true. There's one vertices touching the ground, so it's these conditions become true, and then so we have our setup ready. So like for Suzanne, it's also doing the same thing. It's checking for every vertices of Suzanne. If any of the vertices of Suzanne is touching, then it's gonna stop moving. So that's pretty much what I want to show you today. So it's only checking between selected object and the ground. So if I duplicate this Suzanne, for example, and then rotate it, okay, and once it's touching the ground, it stops moving. See, so let's try it with the torus. Maybe we can make it more clever, like but for now this is kind of pretty good start, I guess, and it can be useful as well still. Let me stop the always execution. Let's supposedly I'll make the ground bigger like that. Let me hide the grid. Display with window. Let's turn off the debug loop, so to make it a little bit faster, just cut it. Here, let me run it. So it's not checking anything. I need to select the objects I want to check. Like that. So seems to be working. Let me just try one more example. Cylinder. Let's try icosphere. See, that's kind of dangerous. So we have these objects, and then let's see if this actually works. Use the template, grid arrange objects. Okay, grid arrange objects. Select the icosphere. It's gonna be the instance. Hit those objects now. Okay, bunch of objects created. Now I'm gonna select those objects and cut this. Probably don't need this anymore. For this bunch of objects, let's place it on the ground. This might not work, or actually it does work. Oh yeah, so it's working. So there you go. Calculator always. So there you go. So that's how we could set up um, animation nodes so that it could do this kind of collisions checking, I guess, ground collisions checking for objects, for each selected objects. And then, like I said, with the magic node, is doing it live. It's almost like a solver, like a, it's not yet a relaxed solver. Really, what I want to create is another similar setup where we can check for every object and then see if each one of them is touching, and then if they're touching, maybe wiggle them slightly until they're not touching anymore. It's kind of like a, in some 3D package it's called like a relax simulation. So until the objects are not touching, and then it's ready for something like rigid body dynamics. Because if the objects are touching, normally the simulations will explode. And this is kind of nice to have. Like if you are doing a layout job and then you want to place objects, you don't need to do it by hands. You just do it like this, right? So hopefully you find this useful. I might put the setup inside at Blend Swap for you to download. But if you want to create it yourself, and you will learn, of course, you will learn more. Of course, you can watch the video again. And thanks a lot for tuning in and watching this video.